Hello, let's take a look at your MT6 and LT6-7 seminar and look at our state standards. We're still going to be proving theorems about triangles. We're going to be doing a bunch of mathematical practices. And what I want you to do is prove and apply the triangle inequality theorem, and we're going to compare triangles too. We're going to look at inequalities in two different triangles versus just one. Now, our first one is called the triangle inequality theorem, and it says this. If I've got three lengths, how do I determine if it's a triangle? And what it happens is I'm going to take the sum of the two lengths has to be greater than the length of the third side. So let's take a look at a couple examples here using our three segments. I've got 4, 5, and 7. Notice 4 plus 5 is bigger than 7. So I should be able to make a triangle out of this. I would like to put the 7 here on the bottom. And then I will put the 4 over here. And I will match them up there. And then I could turn that 4 any place I want. I'm going to put that with the 5. And I can make a triangle. We'll give them to match up there. And if you notice on this one, I can show the circles I'm making. So if my circle with 5 and 4, notice where they cross, I get a triangle. I don't got them quite matched up there. We can see that. Now, what happens if I change that bottom length to a 9? Or actually, let's change it to a 14. Now, when I push this on the edge, notice there's no way they're going to match up. So it kind of makes sense that, hey, if the two sides don't add up to be more than the third side, then I don't get a triangle. But what happens if it's exactly the same, like a 9 here? Well, if that's the case, notice what happens. They only match up right here. Whoops, let me pull that right there. They only match up right there. That's your segment addition. So equal is not good enough. It's got to be more than the third side to be a triangle. So we can apply that on these problems here. If I have sides of 9, 12, and 18, will that be a triangle? Well, look at your two smallest sides, 9 and 12, and I'm going to compare that to 18. So if I do that, 9 plus 12, that is 21. 21 is greater than 18. So yes, this is a triangle. Now if I look at my next one, I've got 3 and 8. Or 3 and 5, sorry. I'm going to compare that to 8. So if I take 3 plus 5 and I compare that to 8, well, 8 equals 8. That's not greater, is it? So that's not a triangle. So given three lengths, you should be able to determine what makes a triangle. Now let's look at a design problem here. I got this delivery company. They use drones to make deliveries around the city. A drone leaves the home office and flies 8 miles east. So I'll make a segment here. East, we're going to the right, and that's going to be 8 miles. And then I'm going to go 4 miles south and west. So over here, that's going to be 4. What could possibly be the length of the third side? Well, if the third side is my biggest side, I know 8 plus 4, that's 12, isn't it? So in other words, 8 plus 4 has to be less than 12. Not equal to, but less than 12. However, no one said the blue segment is going to be the biggest side. If the blue segment isn't the biggest side, then I'm going to say, oh, 4 plus, let's call this x, has to be greater. Whoops, forgot my x. Let's try that again. 4 plus x is greater than 8. So I minus 4 from both sides. And x has to be greater than 4. So in other words, my value of x has to be less than 4. It's got to be bigger than 4 and less than 12. Now the question, what's the least possible whole number? So the smallest whole number I could get would be 5. Now if we look at this, I did all that work, but there's actually a shortcut here. If I'm given 2 lengths, 8 and 4, I get 12. 8 minus 4, I get 4. So to find the possible length of your third side, you add and subtract. Add will give you the biggest it could be. Subtract will be the smallest it could be. And on this one, they just wanted the smallest whole number side we could have, and that would be 5. So it's the same thing that we did with the triangle inequality, except we got some numbers here, don't we? Maybe I should have said 8 plus 4. Whoops. Should have maybe said here 8 plus 4 has to be less than the third side. And there, that's how we get our 12. So it's in between 4 and 12. Any number bigger than 4 and less than 12, notice there's no line under it, so it doesn't include it, will make a triangle. And then our smallest one, that whole number one, that would work. Now, if you did like 4.01, it would be an extremely obtuse triangle. And then based on the directions, we'll learn later how to actually find that missing side. But right now, we're just going to look at, is it a triangle? There we have it. Okay.